That's a lot of things. I got YouTube right now.
I want to answer two fantastic questions that came up during break, and I want to make sure you guys heard them all. The first was, what happens if, in this red one, for example, it doesn't go 0, 1, 2, like it's doing right now, it's going 0, 1, 2. It's very easy to find a number halfway between 0 and 2, it's 1, just like it was over here. That's fantastic. Part of the problem is, what if it goes 0 to 3? Well, if it goes 0 to 3, suppose I grouped it differently, 0 to 3.
It is.
It goes 0 to 2. It's because it's diagonal, it's kind of hard to see. This red bar is 0 to 2, then 3 to 5, then 6 to 8. So in other words, they're 3 wide. If it's 3 wide, using the idea of a median, we just pick the middle number. But what if it's 4 wide, 0 to 3? You pick the middle number, which is, Carly?
1.5.
1.5. Remember what happens? We had this happen to us in class. Although in class, with the keys, there were 2 of the same middle number, 4 and 4, so we just use 4. But if there are 2 numbers in the middle that are not the same, say 3 and 4, just go 3.5. 1.5, 4.5, 7.5. That's all. There's always going to be a middle value. Now some of you are going to say, wait, that doesn't make any sense. You can't have 1.5 keys. No, you can't. But you can average 1.5 keys, right? And that's the point. If your group goes from 0 to 3, you don't want to use 1 as an estimate, because then you're estimating too low, because you're on the left side of that bin. You want to estimate the middle of the bin. So 0 to 2, you want to estimate 1. 0 to 3, you want to estimate 1.5. 0 to 4, you want to estimate 2. 0 to 5, you want to estimate 2.5. You see? So you'll pick the middle because the middle is the symmetric point, the flip-flop symmetric point. Is that fair? Great question. Now, Carly asked me that question earlier. I thought she was talking about how wide do you make the bars to make the average as precise as possible. Now, hopefully you can believe that the wider you make the bars, the less precise the average is going to be. I mean, the worst case scenario, obviously, would be making it 1 bar wide and 30 tall. Then you're assuming the average is directly in the middle of the data, which it is in this case, but it might not be in general. So the question is, how wide do you make the bars? That is an answer I cannot give you directly. We have to learn it as we go through the class together. And this is where technology is going to be our friend. We can experiment with how wide we should make it. Kelsey's like, damn it, I want an answer right now. That's good, I love it. Go, Carly, go.
Well, if you'd make the bars wider,
yes.
So like 0 to 3 or 0 to 4, then you'll be more so underestimating, but also more so overestimating.
That's why the variability is going to be much higher. Now, on a curve like a normal curve, a bell shape, the thing is perfectly what I call symmetrical. The left side and the right side look identical. I ran out of time making this sheet. I want to make distributions that are not. Like your key distributions are what are called skewed. There's more on one side than the other. But what you said still holds true. That is going to become more exaggerated. And the difference, this ties into Di's question, the difference is going to be indicative up here in the grouped average. It's still going to center on the correct average of 10, but it's going to vary more widely around that 10. Now Di asked a question, she's like, it never goes to 11. And she's like, it's going to 9, why isn't it going to 11? Fantastic point. She's like, every once in a while, you do see the number 9 pop up there, yes?
It was 9 point something. So
that's the kicker, one that is a 9. Let's get one here, let's get one. It's like a 9.985. Let's get another one here. 9.8, 9.997, 9.8, 9.9. So it's never deviating too far down from 9, say 0.8. Much in the same way, it never deviates too far up from, what do we got? 10 is a bunch of 9s. I think a 9.6 just popped up there, didn't it? That's a rare event, yeah? Because it's 10 exactly. 10.0, 9.9, 10.0, 10.0, 10.0. You see, you get the point. You're tightly wound around that 10. You're going to see more variance with the larger the sample that you pull, only by the fact that you're allowing for more error. But on average, it's still catching that center point. As far as catching, that's a 244 idea of catching a parameter, but we'll come back to that too. Is that fair? So what this is it's the idea of what's called a weighted mean. And I want to pause this for a second to make sure that you guys hear this phrase. A weighted average. So, and I want to do one more of these with you because I want to drive home the point. You know what, let's put it right in the middle. That's fine, but we'll pause it.